Okay, this is 4.3 Notes and Examples, and our objective today is to solve absolute value equations. And remember that absolute value is the distance a number is from zero on a number line. And distance is always going to be positive, meaning that the number inside the absolute value can be negative or positive, so that you'll have a positive distance. For example, the absolute value of 9 is 9, but the absolute value of negative 9 is also 9. Because negative 9 is still, the distance from 0 is still 9 units. So as far as your homework goes, I'm going to do problem numbers 1, 4, 5, 9, and 13 as examples. So number 1 says, find by inspection all values for x that make the following equation true. The absolute value of x is equal to 5. So what number could we put in place of x and the absolute value of that number still be 5? Well, there's actually two solutions. X could be positive 5 because the absolute value of 5 is 5, or x could be negative 5 because the absolute value of negative 5 is also 5. So the solution is 5 or negative 5. Okay, number 4 is a little bit more complicated because number 4 doesn't just have an x inside the absolute value, it has a whole expression inside the absolute value. But what we know is what's inside the absolute value can be positive 7 or negative 7. So we need to find values of x that make what's inside the absolute value equal to positive 7. And we also need to find values of x that make what's inside the absolute value negative 7. Because we know that the absolute value of positive 7 and the absolute value of negative 7, both of those are going to equal 7. So we'll do that on the next page. So I'm going to set up my equation, x over 7 minus 7 equals 7. And I'll set that equation up twice. One time we'll let what's in the absolute value equal 7. And then one time we'll let what's inside the absolute value equal negative 7. So we'll solve both of these equations. So on this first equation, we'll move our 7 over. And x divided by 7 is equal to 7 plus 7. So x divided by 7 is equal to 14. So since this is division, we'll times both sides by 7. Cancel. And x could be 98. So if x is 98, what's in the absolute value will equal positive 7. Now let's figure out what value of x will make what's in the absolute value equal to negative 7. So we'll move our 7 over again. And so I've got negative 7 plus 7. So x over 7 equals 0. Then I times both sides by 7. So x could also be 0, and that will make what's in the absolute value negative 7, but when we take the absolute value of negative 7, we'll still get positive 7. I'll show you that on the next page. We're going to check these answers and show you that those are true. Okay, so here was my original equation, and we got two solutions. We got x could be 98, or x could be 0. So let's check both of those solutions and see if it does make our equation true. So I'll take 98 in place of x. And 98 divided by 7 is 14. And 14 minus 7 is 7. And the absolute value of 7 is 7. So 98 checks, it makes the equation true. So I know that one of my solutions is 98. Now let's try the same thing with the 0. So in place of x, we're going to put 0. Keep our absolute value bars. 0 divided by 7 is 0. And 0 minus 7 is negative 7. And the absolute value of negative 7 is positive 7. So 0 also makes the equation true. So we found our solutions for number 4. Our solutions are x can be 0, x could be 98. So we'll put 98, 0 as our two solutions. Okay, number 5 is a little different because I have x inside the absolute value, but I have a minus 8 outside the absolute value. So the big thing you have to remember on these problems is you have to move everything that's outside of the absolute value to the other side of the equation first, and then you can set up your equation to make it equal the positive and negative. So I'll show you how to do that on number 5. So we're going to move our 8, since it's not in the absolute value, to the other side. So I'll have the absolute value of x is equal to 1 plus 8. So the absolute value of x is equal to 9. So remember, what's in the absolute value could be positive or negative 9. So x could be positive 9, or x could be negative 9. So the solution here is 9 or negative 9. Okay, let's do number 9 here. So what's in this absolute value, 10x minus 12, could be positive 4x plus 12, or it could be negative 1 times 4x plus 12. So this could be 10x. Let me do this on another page here. So the way to do this one is to say that 10x minus 12 could equal positive 4x plus 12. So we'll solve that equation. So move my like terms together. So I've got 10x plus negative 4x could equal 12 plus 12. So we got 6x could equal 24. And divide both sides by 6. So x could be 4. But then remember, we want to set it up where it could be the negative of that also. We'll do that on the next page. So 10x minus 12 could equal negative, and be careful here, I would put this in parentheses, it could be negative 4x plus 12. So we need to make sure that we turn both the 4x and the 12 into a negative. So I got 10x minus 12 could be negative 4x minus 12. Move my like terms together, so I've got 14x over here. When I move my 4x over, it'll be plus. And then when I move my 12 over, it's going to be positive 12 minus 12. So that's going to be 0. And then if I divide both sides by 14, x could be 0. Now let's check and see if our solutions are correct. So our solutions were 4 and 0. So we're going to check and see if those are right. So our original problem was 10x minus 12, the absolute value of that should equal the absolute value of 4x plus 12. So let's substitute our solutions and make sure that those are making the equation true. So if I substitute 4, it's 10 times 4 minus 12 should equal the absolute value of 4 times 4 plus 12. Well, 10 times 4 is 40, and 40 minus 12 is 28, and the absolute value of 28 is 28. And on the other side, 4 times 4 is 16, and 16 plus 12 is 28. And the absolute value of 28 is 28. So the 4 definitely makes our absolute value equation true. Let's try the 0 next. So we'll start by substituting 0 in place of x. So 10 times 0 minus 12. And then on the other side, the absolute value of 4 times 0 plus 12. So 10 times 0 is 0, and 0 minus 12 is negative 12. but the absolute value of negative 12 is positive 12. 4 times 0 is 0, and 0 plus 12 is 12, and the absolute value of positive 12 is also 12. So 0 does make our equation true. Okay, the last problem that we want to do is number 13 here. And it says write an absolute value equation for all numbers x whose distance from 9 is 19 units. So that means that the number x minus the 9, the absolute value of that, is going to equal 19. So remember, for absolute value equations, it could be what's inside the absolute value, x minus 9, could be positive 19, or what's inside the absolute value, x minus 9, could also be negative 19. So then we'll move our 9 over. So we got x could be 19 plus 9, which is 28. Or x could be, if I move this 9 over, it could be negative 19 plus 9, which is negative 10. So x could be 28, or x could be negative 10. So the equation is x, the absolute value of x minus 9 equals 19. Now all they want here is the equation, not really the solutions, but I kind of had to do the solutions to see if my equation made sense. You know, if you think about on a number line where the number 9 is, think about what two numbers would be 19 units away from 9. Well, if I go 19 units this way, I would add 19 to that and I would get 28. If I go 19 units this way, I would subtract 19 and I'd be at negative 10. So our solution, you know, makes sense that it could be 28 is 19 units away from 9 and negative 10 is also 28 units away from 9 in the opposite direction.